if you watched your Can You Do solutions, they ended up being really long because there was some stuff in the lesson that I didn't get to that ended up being important for your Can You Do. So I want to make sure that we take as much time as we need today. Like you can see on our agenda board that maybe we'll get to lesson 3 because I want to make sure that I give you guys as much time as you need to ask questions or to work on the ideas in this Can You Do so that you can feel as good about it as possible. I was going through these examples on 506 with my B-Day classes, and we did example 2, the bananas example. And toward the end, I'm saying, okay, does this make sense like I always do? And there's like a few kids that are like, yeah. And then afterward, one of my girls comes up and says, I still don't understand it. And I was like, babe, why didn't you say something? And she's like, well, everybody else was saying yes, so I didn't want to say no. And you guys have to keep in mind that, like, just because 2 people feel like they have an idea about what this all means doesn't mean that everybody does. And even if you're the only one that doesn't, so what? So what if you're the only one? I was often the only one, and I just asked the questions anyways because it was my grade that I had to worry about and not anybody else's grade. So if you don't feel comfortable saying something like in front of everybody, I'm going to give you some time after we go through these just to look through your Can You Do and talk to each other if you need to. Stop me then, and I'll go through it with you so that you don't have that pressure of having to feel like, well, I'm the only one that doesn't understand it. Shelby Green, she's our president. I think she's our SBO president. Is that true? Do you guys know? Shelby Green, I had her last year in AP Stats. She ended up getting a 4 on the exam, which was really, really good. She's my TA, so she's listening to me teach this yesterday, and she's like, this is triggering me a lot. And that's because this is one of the hardest things to understand in AP statistics. And in particular, problems like this one right here. She's like, it took me like a month and a half before I felt like I fully understood what these kinds of problems were asking me. So I'm only telling you that so that you guys know that if this is something that you're like, what is she even talking about? That's normal, and all we can do is try to see enough of these problems that hopefully one time it clicks for you. So that all being said, we're gonna run through problem or example 2 on page 506. And it's the example called bananas. So if you're not there yet, get there, and we will go through this together. So we have this grocery store manager. The setup for this problem is that there's a grocery store manager that claims 75% of his shoppers buy bananas at least one time per month. So his claim is that 75% of his customers do this. So I'm going to write down in this space that the claim for his store is that P is 0.75. Then it gives us all this information about sampling, and at the very end, it says, our grocery store manager takes a sample of his own customers. He looks at 100 of his own customers and gets a sample of 64 that bought bananas in the last month. So our manager's sample is 64 out of 100, or 64%. So the foundation behind this problem is our store manager claims 75% of his shoppers buy bananas in the last month. We take a sample, and it's kind of low. It's 64%. So the question is his sample so low that we would question whether or not this is true? Like maybe he uses this number to predict how many bananas he needs to buy. So it's important when he's budgeting his resources that he's accurate about the things that he needs to purchase. So he gets this sample and we're thinking, well, maybe he needs to adjust. Maybe it's not really 75. So how do we decide? How do we decide if this is low enough that he needs to look at adjusting his numbers? Well, we go to Truthland. This guy is the truth. This is Truthland. What this dot plot is showing us is we had a population that truly had 75% buy bananas. So this is the truth. We're not questioning it. This information for sure comes from a population where 75% of the people buy bananas. And we look, what we have here is from this population where it is for sure that 75% buy bananas, we get these 250 samples. So there are 250 dots here. And each dot represents a sample and how many of the customers bought bananas. So like this one dot here is probably a sample where 84% of the customers bought bananas. You have a bunch of samples where 75% did, and it looks like 73% did. The question is, in Truthland, if we pulled a sample from the population where 75% bought bananas, how many times did we get a sample that was 64%? None. So 64 would be like here. Out of 250 samples from this population, none of them were 64. Okay, well, what about 64 or less? Well, then, if we look at 64 or less, we have one sample. One sample out of 250 was that low. That's a pretty low number, would you agree? Out of 250 samples, only one of them was this low. What that tells you is this manager's claim cannot be true, because this comes from a population where it's true, and there's a very low chance that we just got unlucky and ended up getting a super low number of people that bought bananas. It's more likely that he's wrong and he doesn't really have 75% of his customers that buy bananas. Does this make a little bit of sense? So this is the truth. These people really buy bananas 75% of the time. You take a bunch of samples, and in all those samples, only one time did we get a number that low, which says to us, this is evidence that our grocery store guy is wrong. It's very unlikely that he would get a sample that low if his proportion is truly 75%. And that is related to this first can you do question on 52, where you're talking about doing homework. So I'm going to run through how you word this answer now, and then we'll check in on number 1 and just make sure that we're clear on what's happening in number 1. So how we would word this answer, because the question that they're asking at the end is, does this sample provide evidence that the grocery store manager overstated the true proportion? So when they say this sample, they mean the grocery store guy's sample. So we're going to say this sample provides evidence that the true proportion is not 0.75. And that's not all we have to write. That's just the first part. That's just answering the question. Then we need to justify it. Based on the dot plot, okay, now I'm going to say a lot of words, but I'm going to translate them to math symbols. So based on the dot plot, the percent or the probability, so capital P, that we would get a sample that is 64% or less is 1 out of 150. Sorry, I said 250 earlier, but it was really 150. If we translate that to a percent, that's approximately 1% of the time. So it is not plausible So not plausible means not reasonable. So it is not plausible to get a p hat of 0.64 if p is truly 0.75. So essentially we're saying there's no way for this manager to get the sample that he got if 75% of his customers really buy bananas. How do we know that? Because in a sample of 150, that only happened one time. And there's no way that we're that unlucky, that we just happen to get this one sample. You're hanging in? Okay, so now I'm going to transition to 52. Number 1 on 52. So it wants you to identify what the 1 point at 0.73 is. So in our notes, I went back in the solutions video and interpreted or wrote down how you describe one of these points. So I went back to our example of the left-handed students, and in the solutions video said, in our notes, we would have interpreted this guy as one sample of 50 students where 13% of them were left-handed. So if we transition to the homework problem, how we would interpret the point at 0.73, this is one sample, and this is a simulated sample. One sample of 100 students where 73% of them did all of their homework last week. So that one dot represents one sample. The next question says, would it be surprising to get a sample 45 or lower? So would it be surprising to get a group of 100 students where 45% of them did all their homework last week? So we need to go up to Truthland. And we need to look at what happens if the proportion is truly 60. How many of these samples were 45 or less? How many? 0. None of them. 0 out of, this is the one that's 250. The percent of our simulated samples that are 45 or lower this time truly is 0. So would it be surprising if we randomly looked at 100 kids and 45% of them said they did their homework last week? All of it. Yes, it would. Because in Truthland, none of our samples were that low. So that's how I would frame that answer. Yes, it's surprising because in our dot plot of 250 samples, we never got a sample that low. Then that reasoning, they are prompting you to think about that so that you can answer the next question. Suppose that these AP students actually go and take a sample of 100 kids. So suppose that Brinley is going to go track down 100 kids. She's going to ask them how many did their homework or if they did their homework, and she gets 45% of them say, yes, they did. Is this evidence against the newspaper's claim? You would say yes. There's no way that 60% of the students at Cypress did all their homework last week if Brinley gets a sample that low. So the claim must be wrong, at least for whatever student she's looking at. And that's what the solutions video guides you to answer. So part B, they're getting you to think about how unusual that number would be. And then part C, they want you to recognize that you can use that as evidence that the claim is not true. I think that that is the only one of those problems in our Can You Do. So I want to give you some time to just read through those and stop me and ask me questions if you have them. I just want to remind you that you've seen this before at the very beginning of our class. I don't know if I kept my paper. Yeah, in the smelling Parkinson's disease, we talked about this a little bit. So if you felt like you understood it when we talked about the Ford Focus and the kids that could smell Parkinson's, you might want to look at that as well. So maybe should we go 5 minutes? And if you're Gucci, you can study or look at Tic-Tac or whatever. But if you need help, you're going to stop me and I'm going to help you, right? Okay, go. So you're going to see if you feel good about number 1, and then we'll come back to this paper and do example 1. Okay, so I just want to clarify a couple of things now that I've answered some of your questions. I think I'll use the grocery store example because that one seems to make a little bit more sense. So one thing that I want to clarify is that in the dot plot is not the grocery store's customers. It's a completely different population where we know the truth is P is 0.75. So this value is true no matter what. We're not testing if the dot plot, the information in the dot plot is true. We know it's true. Even if there would have been 4 samples down here, this is still a P of 0.75. His claim is separate from this dot plot. His claim is, do 75% of my customers buy bananas? These are not his customers. This is just an example of what the dot plot would look like if they truly bought bananas 75% of the time. So you're using this that is true no matter what to decide if his group of customers are at a P that's that value. It's the same with these students. These are not the students that go to school with these skeptical AP students. So the setup for this is that this article claims that in general, no matter what, students at large high schools, 60% of them do their homework. Well, you look at your school and you're like, well, do 60% of the kids at my school do their homework? So you take a sample and get one that's low. This is not the kids from these guys' high school. This is a made up true population where 60% of the kids do their homework. So I'm hoping that that helps a little bit. The other thing that we got into last time was something being a biased and unbiased or unbiased estimator. And I think one of the confusing parts about deciding this is in our notes, we say, morning. Good. She dropped. I think she just dropped this house.
What? Can you tell how good I'm doing this fucking game?
Okay, so I made to distinguish in our notes that it's unbiased if your mean equals the true value, but then all of the examples that we see are talking about center. So why are we focusing so much on it having to be the mean if these examples are all talking about center? So let's look at this Old Faithful example, and hopefully that will help us a little bit with that question. So the histogram below shows the intervals in minutes between the eruptions of the Old Faithful geyser for all 222 recorded eruptions during a particular month. For this population, the median is 75. So this histogram is the population, and the true median is equal to 75. They want to know if these samples give an unbiased estimator. Why would we do this for a population in which we know the truth? Well, the only reason we're doing this is so we can learn about biased and unbiased estimators. If we know the truth, we're not going to then go take a sample. We're just doing this to see if we understand a biased estimate. So then it goes on to say, we used Fathom software to take 500 simple random samples from the population. So these samples are actually from the population, this population of eruptions. The 500 values of the sample median are displayed in this histogram. Okay, so what they're saying is they found the median of each sample. They didn't find the average or the proportion. They found the middle value in each of their samples. And that's this plot here. So this is the sample medians. And then the one value that they give you is that the mean of these is 73.5. So what they did was they took all of the sample medians, added them together, and divided by 500. So they give us that the mean sample median is 73.5. Is this an unbiased estimator? Well, if true median is 75 and the average of our sample medians is 73.5, then this is a biased estimate. Your average sample value has to equal the true value or it's biased. So on this one, we say it's biased because the population median is not equal to the mean of the sample medians. So the idea behind this is we know the true value. The true value is 75. If we took a sample, would that sample be a biased or unbiased estimator? Well, the issue is when you take samples, you often get a different value each time that you take a sample. So you take one sample and get a median of 70, but then you take another sample and get a median of 70.5, and another one and it's slightly different, and another one and it's slightly different. And then eventually you get all those medians and you can plot them. Well, that's okay that they're all different as long as most of them are around the value of 75. To find out if most of them are around 75, you find the average of all those medians. And it turns out that average is lower. It's 73.5. So most of our samples were not 75, they were lower. So this is a biased estimate. It doesn't do a good job of estimating our true median. What does our next question ask? Suppose we had taken samples of size 20 instead of size 10. Would the spread of the sampling distribution be larger, smaller, or about the same? So the spread of the sampling distribution would decrease. The bigger your sample is, the more smushed in your sample values get to a value, to a specific value. So this is the spread for samples of size 10, but if we took samples of size 20, this would move in a little bit. Because the more information you get, the closer you get to the truth. So 20 eruptions would get us closer to the truth than 10 eruptions would. So I'm just going to make a note here that when n increases, variability always decreases. If you increase sample size, you will always decrease variability. Okay, let's see how that translates then to number 2 on the can you do. This small internet mail order company keeps track of the orders that it sends out on time. They do this for several years and they run the summary statistics on their information. So this is their 5-number summary. They're saying that when they plotted this data, it was right skewed and had these values for min, quartiles, median, and max. They're going to take, or suppose we take, a random sample of 40 days from the days that they collected. So they collected years worth. So over 1,000 days probably. We're going to look at 40 of those days, and they want us to calculate the range. This company is interested in the range for each day. Or the range for each sample. Sorry about that. Okay, so what was the range of the population? So let's come up here by the population and let's find the range. Well, that's the max minus the min. Your max is 80, your min is 20, so your range is 60. So the number of orders you filled on a given day, the range was 60. Between the highest number of orders they ever filled and the lowest order of numbers they ever filled was 60. So I'll say that one more time. Of all the days that they looked at, the range was 60. So between the highest and lowest was 60. So the most they ever delivered on time was 80, and the least they ever delivered on time was 20. So what you're seeing in this dot plot is all of your sample ranges. So you took a sample of 40 days, did the maximum they filled in that 40 days, the minimum they filled in that 40 days, found the range. They did this 50 times. So 50 samples where N is 40 days. There are two dots at 53. Explain what these values represent. So we had two samples of 40 days where the range in orders filled on time was 53. Now B is the heart of the matter. Is the sample range an unbiased estimator of the population range? Use the dot plot to decide your answer or to justify your answer. So they are asking if population range equals the average sample range. Well, to find the average sample range, we would have to enter in all 50 of these ranges into our calculator and use our calculator to find the average, or we would just need to manually add them up and divide by 50. Is it doable? Sure. Do we want to do that? No, I don't want to do that. And this is where the center comes in. The center is a shortcut. Using the center of a distribution is a shortcut to answer this question. We can use the center because this is approximately symmetric. And when a distribution is approximately symmetric, mu equals the median. So instead of adding up all 50 numbers and dividing by 50, we take a shortcut and find the median instead, because these two should be about the same. So I go through and find the median, which I already did. I counted to the 25th observation, and your median lands on 57, a range of 57. So we ask ourselves, is 57 the same as 60? Did these equal? No. So this is a biased estimator. This is biased. Why? Because your population range does not equal the average of your sample range. The average of your sample range is about 57. Just to show you that this truly works, I put in the values and found the actual average of these ranges. The actual average is 56.8, I believe. I wrote it down somewhere. I'm pretty sure it's 56.8. Which rounds up to 57. So if your distribution is symmetric, like you see in our examples on our note sheet, all these examples were symmetric. Like this one was a no, but this is symmetric, this is symmetric. This isn't even anywhere close to being unbiased. So the biggest takeaway from this problem is that finding the median is a shortcut. What you're really looking for is the average sample value. You can use this from now on. They're not going to give you examples where you can't find the median. They're always from here on out going to give you examples where the distribution is symmetric and you just have to look at the median. So this guy is biased. That was a lot of information for one lesson. Between deciding if something is convincing evidence and deciding if something is biased, those are two really big, complicated ideas. So hopefully it feels a little bit better. The biggest takeaway, like I said, is using center is a shortcut. We're supposed to find the average, but that takes longer and is more horrible. Are you okay on this one? Yes? Well, I shouldn't ask because I don't think anybody will tell me. And then we talked about, just to finish this up, and then we're done with all this stuff. We talked about before you guys left why we can't use the center of this distribution to decide if it's biased. Because this is the last question on Can You Do 51. This distribution was skewed left. So we couldn't use the center as our shortcut. We actually had to go through, if we want to decide if it's biased, and find the average number of steps. So I went through and added all 10 sample values, divided by 10, and got an average sample value that was equal to the true value of the population. So in this case, center shortcut does not work because it's skewed left. If out of these two ideas, both of them are bothering you, focus on the convincing evidence one. So focus on number one and not number two. If you have to pick and choose where you want to spend your efforts, spend them on understanding this idea and not the mean and center idea. Are you okay? Would you like a minute to wrap this up? This assignment on your own? No? You're done? You're Gucci? You're Gucci? Okay. So set it to the side. I'll come pick it up. And then we'll start. Let's see how far we get in 53, and then I'll tell you what you're going to do on Friday, because we might need to adjust a little bit. So we're starting on page 507. We might get as far as, well, maybe just take out 507 for now. Okay. Here we go. So, we talked about last time how... Oh, I should stop.